Hi, I'm Patrick Reagan. Welcome to Networking, Part 8, IPv4 and IPv4 Addressing. In this video, we'll discuss how hosts and IP addresses are assigned and used. Topics include IPv4 addresses, subnet mask, default gateway, and DNS servers. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Each connection on a TCP/IP address or logical address is called a host. A host is a computer device with a network interface that is running TCP/IP and that is assigned a unique logical address such as 192.168.5.243 or 50.233.23.17 that acts as a digital home address. This is called the logical address because the IP address is assigned to a device on a network, but it's not tied to the physical hardware like a MAC address, and it can be changed or reassigned by software or network configuration. You'll need to include addresses for computers, servers, remote access management ports for servers, network printers, connection for routers, and management ports for routers and switches. When planning a TCP/IP network, make sure that you think of potential growth where additional hosts may be added to the network in the future. For a host to communicate on a network, it typically needs an IP address, which is a unique logical address assigned to the host, a subnet mask, which specifies which bits of the IP address is network bits and which bits are host bits. Subnet mask will be used to determine if destination packets are local or remote. Default gateway, the IP address of the nearest router, which allows communications with other networks. And DNS server, which is the IP address of a DNS server, which will provide name resolution to IP address. Without proper DNS resolution, most services and access will fail. This figure shows the configuring IP configuration in a Windows computer. In this figure is using the ipconfig/all command to display the IP configuration. The IPv4 address space consists of 32-bit addresses notated as 4 8-bit decimal numbers from 0 to 255, separated by periods, as in examples 192.168.43.100, 131.107.3.1, and 2.0.0.1. This is known as dotted decimal notation, and the individual 8-bit decimal values are called octets or bytes. Remember, when you have 8 bits, there are 2 to the 8th, which is equal to 256 combinations, which is represented by an octet. Since the address is used to identify the computer, no two connections can use the same IP address on the same network. If there is, one or both of the computers will not be able to communicate. A subnet mask is another 32-bit value consisting of binary 1 bits and 0 bits. Subnet masks specify which bits are network bits and which bits are host bits. When compared to an IP address, the bits corresponding to the ones in the mask are the network bits, and the bits corresponding to the zeros are the host bits. Subnet mask can be shown as CEDAR, which specifies the number of network bits. Example, 255.255.255.0 is expressed as /24 because 24 bits are network bits. All computers on the subnet should have the same subnet mask. Remember, for subnet mask, you should have all ones on left side and all zeros on the right side. The default class subnet masks are: Class A networks have 255.0.0.0 or /8 CEDAR notation, which indicates that the first 8 bits are network bits and the last 24 bits are host bits. Class B networks have 255.255.0.0 or /16 CEDAR notation, which indicates that the first 16 bits are network bits and the last 16 bits are host bits. Class A networks have 255.255.255.0 or /24 CEDAR notation, which indicates that the first 24 bits are network bits and the last 8 bits are host bits. Here's an example of an address of 192.168.43.100 with a subnet mask of 255.255.255.0 or /24 Cedar notation. The first three octets, 192.168.43, identify the network. Remember, the ones of the subnet mask indicate the network bits. The network address is 192.168.43.0. The last octet, .100, identifies the host as identified by the host bits. Remember, the zeros of the subnet mask indicate the host bits. Think of host.100 is located on network 192.168.43.0. With classful addresses, by default, Class A addresses start between 1 and 126, which has a default subnet mask of 255.0.0.0 or /8. By default, Class B addresses start between 128 and 191, which has a default subnet mask of 255.255.0.0 or /16. By default, Class C addresses start between 192 to 223, which has a default subnet mask of 255.255.255.0 or /24. 127.0.0.1 address is a reserved address called the loopback address, which points to a local host or itself. In fact, the entire 127.0.0.0 network is reserved for loopback addresses. If you ping 127.0.0.1, you're basically pinging yourself, which is used to test if the IP protocol stack is running on your machine. The RFC 1918 private address is reserved for private internal networks and cannot be routed on the public internet. This allows organizations to use these addresses locally without conflicting with public IPs, conserving the limited IPv4 address space. This potentially gives every corporation or organization up to 48 million addresses to use for their internal network, more than enough addresses to connect all of the sites and subnets. These addresses are not available on the internet. Most enterprise networks use addresses from these blocks for the internal host and network. RFC 1918 private addresses are often used with Network Address Translation, or NAT, which allows internal network devices to communicate with external devices on the internet by translating private IP addresses to a public IP address assigned to the router or firewall. It does not matter if other organizations use the same addresses because the hosts are never directly connected to the same network. You should never see traffic from the internet come from these private addresses, which is ingress or incoming, since the address ranges are not routable on the internet. Network Address Translation, or NAT, is a network layer routing technology that enables a group of workstations to share a single registered address. A NAT router is a device with two network interfaces, one connected to a private network and one to the internet. When a workstation on the private network wants to access an internet resource, it sends a request to the NAT router. Normally, a router passes traffic from one network to another without modifying the data. However, in this case, the NAT router substitutes its own registered IP address for the workstation's private address and sends the request on to the internet server. The server responds to the NAT router, thinking that the router generated the original request. The router then performs the same substitution in reverse and forwards the response back to the original unregistered workstation. The router, in essence, functions as an intermediary between the client and the server. A single NAT router can perform the same service for hundreds of private workstations by maintaining a table of the address substitution that it has performed. In addition to conserving the IPv4 address space, NAT also provides a certain amount of protection to the network workstations. Because the workstations are functionally invisible to the internet, attackers cannot readily probe them for open ports and other common exploits. Here, we have a static network address translation that has a one-to-one mapping to or from a public IP address to a private address. When 192.168.0.101 communicates to the internet, the router will convert the outbound addresses from 192.168.0.101 to 180.12.18.101. When the internet system communicates back to the client, the router will convert the destination address of 180.12.18.101 to 192.168.0.101. Network Address and Port Translation, or NAPT, also known as Port Address Translation, or PAT, or NAT overload, maps multiple private IP addresses to a single public IP address by using unique port numbers, allowing many devices on a private network to share one internet connection. This technique conserves public IP addresses and enhances security by hiding internal IP addresses from the external network. The default gateway specifies the router on the local network, specifically the link of the router on the same subnet. You need to communicate with other subnets, you need to specify the default gateway. Think of it as the gateway or doorway to get out of your local area network. The default gateway must be an IP address on the local subnet. Any packet that are sent to other subnets, these packets will be sent to the router, which will then figure out the best way to get to the remote subnet. The default gateway should have the same network address and subnet mask that the client has. Domain Name System, or DNS, is used to resolve the names to IP addresses. A Uniform Resource Locator, or URL, is the unique address of a specific resource, such as a web page on the internet. It functions as a digital roadmap, guiding a web browser to find and display the requested content when you type or click it. A complete URL includes a scheme like https://, a domain name, such as the website's name, and often a path to a specific page or file within this website. For example, https:// www.microsoft.com/en-us/Microsoft-365. www.microsoft.com might resolve to IP address of 23.37.18.39, which represents the Microsoft server. When configuring your IP configuration on a host, you need to specify one or more DNS servers that the client can resolve named to IP addresses. You should specify a second DNS server for redundancy, in case the first DNS server is not available. Without working DNS, you will not be able to do much. For clients, you should avoid static IP configuration, where you will have to manually configure the IP address, subnet mask, default gateway, and DNS servers for every host on your network. Dynamic Host Configuration Protocol, or DHCP, can automatically perform IP configuration including IP address, subnet mask, gateway, and DNS server. The client has its IP configuration including IP address, subnet mask, default gateway, and DNS servers for a specified amount of time as dictated by the DHCP administrator. You need to make sure the client gets a specific IP address or the same IP address. You can use a reservation that's based on the system's MAC address. The DHCP server is not on the same subnet as the client making the request. An IP helper or DHCP relay agent will be listening for those broadcasts and will forward them directly to the DHCP server. Remember, broadcasts do not typically go through routers. Automatic Private IP Addressing, or APIPA, is a non-routable linked local address that is assigned when a client cannot find or connect to a DHCP server. It will assign itself an IP address. IPIPA address begins with 169.254 and has a subnet mask of 255.255.0.0. Therefore, if you see a client that has an address that begins with 169.254, make sure the computer is connected to the network, cables or wireless connection, the DHCP service running that handles the automatic configuration of the system, and that the DHCP helper or relay agent can forward the DHCP request to the DHCP server. In Windows, to see your IP configuration, open a command prompt and execute the ipconfig and ipconfig/all command. Question: what are the 4 necessary components that you have to configure for IP version 4 so they can connect to the network and surf the internet? Answer: IP address, subnet mask, default gateway, and DNS server. Question: which of the following statements must be true? Answer: a host must have a unique IP address. Question: what specifies the router for a client to communicate with remote networks? Answer: default gateway. Question: how many octets does an IPv4 address have? Answer: 4. Question: which specifies which address bits are network bits and which bits are host bits? Answer: subnet mask. Question: what is the loopback address for IPv4? Answer: 127.0.0.1. Question: a user reports that he cannot connect to any websites. You run the ipconfig command and you see the following: IPv4 address 169.254.254.43, subnet mask at 255.255.0.0, and no default gateway. What is the problem? Answer: not connecting to a DHCP server. Question: which of the following is not a private address? Answer: 172.254.3.4. Question: what is the default subnet mask for a Class B network? Answer: 255.255.0.0. Question: which of the following is not a private address? Answer: 200.24.43.3. For more information, visit these sites. In summary, a host is a computer or other network device that's connected to a TCP/IP network. For a host to communicate on a network, it typically needs an IP address, which is a unique logical address assigned to the host, a subnet mask, which specifies which bits of the IP address is network bits and which bits are host bits, a default gateway, which is the IP address of the nearest router, which allows communications with other networks, and DNS server, which is the IP address of a DNS server, which will provide name resolution to IP address. The IPv4 address space consists of 32-bit addresses notated as 4 8-bit decimal values from 0 to 255, separated by periods. This is known as the dotted decimal notation, and the individual 8-bit decimal values are called octets or bytes. The subnet mask is another 32-bit value existing in binary 1 bits and 0 bits. Subnet masks specify which bits are network bits and which bits are host bits. The IPv4 loopback address is 127.0.0.1. The RFC 1918 3 blocks of addresses allocated for private use are as follows: 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. These addresses are not available on the Internet. Dynamic Host Configuration Protocol, or DHCP, can automatically perform the IP configuration, including IP address, subnet mask, gateway, and DNS server. Thank you for watching this video. The next video will be networking Part 8, IPv6 and IPv6 addressing. If you like this video, don't forget to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel. Thank you.